In this second video here, we're going to look at two more examples, and in both of these we are going to use the integral test. For the first one, we have the series, which is the sum from n is 2 to infinity of ln of n over n. So I'm going to use the integral test here, and we're going to look at the integral from 2 to infinity of ln of x over x dx. Now I'm going to rewrite this. It's the limit as b approaches infinity, the integral from 2 to b, and here I'm going to rewrite this as the natural log of x times 1 over x dx. So here I have the natural log of x times its derivative. So I'm going to do a u substitution without doing a u substitution, if that makes sense, where my u would be the ln of x, the natural log of x. Here's my du. So when I integrate, I'm going to have the natural log of x squared over 2. So I have the limit as b approaches infinity of the natural log of x squared over 2. And we're going to evaluate from 2 to b. So I have the natural log of b squared over 2 minus the natural log of 2 squared over 2. Well, as b goes to infinity, the natural log of b is going to go to infinity as well. So we end up here with infinity. This is going to diverge. And because the integral diverges, so does the series. Now for the second one, we have the series, which is the sum from n is 3 to infinity of 1 over n over the natural log of n times the square root of the natural log of n squared minus 1, which is a mouthful here. We're going to use, again, the integral test. So we're looking at the integral from 3 to infinity of 1 over x over the natural log of x times the square root of the natural log of x squared minus 1 dx. So I alluded to a u substitution in the previous example. Here we're actually going to do the u substitution. I'm going to let u equal the natural log of x. And apologize if you're picking up any background noise. My one cat has decided that he's going to help me today. U is the natural log of x, so the derivative there is 1 over x dx. So I can rewrite this, and I'm going to do several things here at once. This is going to be the limit as b goes to infinity. Since u is the natural log of x, okay, the natural log of infinity is still infinity, so it doesn't impact this upper bound. But the lower bound, instead of being a 3, will be the natural log of 3. The 1 over x in the numerator and the dx, that's just my du. In the denominator, I've got u times the square root of u squared minus 1. And if you look at your integral tables, this is going to come from number 61 on your integral tables. You'll be able to integrate this. So again, that's number 61. So we have the limit as b goes to infinity of inverse cosine of the absolute value of 1 over u. And we're going to evaluate that from the natural log of 3 to b. So substituting in, we have the limit as b goes to infinity of inverse cosine of 1 over b, or the absolute value of that, minus inverse cosine of the absolute value of 1 over the natural log of 3. As b goes to infinity, 1 over b goes to 0. So we're looking at the inverse cosine of 0, and the inverse cosine of 0 is just pi over 2. So this is equal to pi over 2 minus the inverse cosine of 1 over the natural log of 3. That is positive, so I can drop the absolute value bars. This converges. This is an actual value. So because the integral test, because this integral converges, we can say that the series also converges.